Hi everyone, I am here with another interesting array problem. This is finding equilibrium point or index in an array. So what is an equilibrium point or index? So equilibrium point is the position in an array in in which the sum of all elements to the left side of the index is equal to sum of all the elements to the right side of that index. Okay, so let us try to understand this through an example. Suppose the array given is 173656. It contains 6 elements. Then if you observe this one, 173 sums up to 11 and 56 sums up to 11. So what is the equilibrium point or position? This one. So we have to return or we have to print the index of that equilibrium point. So if the index is 0, 1, 2, 3, 4, 5, what is the output we must return here? Output is 3. 3 is the position of the equilibrium point or equilibrium index. Okay, so this is the output we must produce. Here 3 is the equilibrium point or position. Okay, this is a bit of explanation about this example. The elements to the left of the position are 173. The sum of these elements is 11. The elements to the right side of this position 3 are 5 and 6. The sum of these elements is 11. So hence 3 is the equilibrium point and this is the output we must produce. Sometimes there may be cases where we cannot find the equilibrium point. That means there will be no equilibrium point in the array. So that can also be displayed as output. Okay, so let us quickly write code for this one. Here I am going to write an efficient code which consumes big O of n time complexity and big O of 1 space complexity. Okay, so this approach, the one that I am going to use here, is based on sliding window method. So what is sliding window method? In sliding window method, we will consider a portion which is called window and we will move that window from position to position and we will move that in a gradual manner. Okay, so let us see that one. So I will make another video to explain this sliding window method especially, but here let us focus on the solution. So let me write code for this one. First I will write one function e point. E point means equilibrium point, which takes two parameters. The first one is the array or list and the second one is the number of elements. I will consider two variables r sum, l sum. So r sum is to hold the sum of the elements to the right side of the equilibrium point. L sum is to hold the sum of the elements of left side of equilibrium point. Initially I assume that r sum is equal to whole sum of the elements. So sum of A, L sum I assume as 0. Okay, this is my initial assumption. R sum is assumed to the sum of all the elements of the array. L sum is assumed to be 0. Now I will run a for loop for I in range n. I will run a for loop over the array and each and every time I will check whether L sum is equal to R sum. Then you may think that how this L sum will be equal to R sum. So every time in each iteration I will remove one element from R sum. That means if I is assumed as equilibrium point, that A of I is to be deducted from R sum. Then we will check whether L sum and R sum are equal. If they are equal, we will return that index I. Otherwise L sum will be taking that element A of I into it. Okay, so let us see this one. R sum equal to R sum minus A of I. If I is assumed as equilibrium point, I will remove that A of I from R sum. Then I will check whether R sum is equal to L sum or not. Initially in the first iteration this may not be true, but in next iterations and all there is a possibility that this condition may become true. Return I. So If they are same, return I, there ends the job. Otherwise, this L sum is to be added with L sum equal to L sum plus A of I is to be added with that A of I. So in next iteration, again R sum will be deducted with A of I, and we will check whether R sum is equal to L sum or not. In such cases, we will return I, otherwise update L sum. Okay. So if we do this in a gradual manner, then at one point, if equilibrium point is there, at one point L sum will become equal to R sum. Return that position. Sometimes we cannot find equilibrium point. In such cases, return -1. Okay. Now let me write the driver code. We will read input. First I will read n, number of elements. Then I will read the elements of the array. I will name this array or list as A. I am using list comprehension to read this input for I in input dot split. Okay, then I will call this function. Let me hold that return value in x, e point a comma n. If equilibrium point is there, this x will be some position, otherwise it will be -1. Okay. In Python, people may get confused that if -1 is written as position, that may point to last element. No. Here we are not using that negative indexing here. -1 is to report the non-availability of the equilibrium point. Okay. If x equal to -1, print no equilibrium point. Else print equilibrium point or index equal to comma this x. Okay, that's all. This is the code. So if you want to have the code, please pause the screen or pause the video and take a screenshot of this one. Okay, so let me run this code. Let me first give the example we have taken 6 and what are the elements? 1 7 3 6 5 6. 1 7 3 6 5 6. Okay, very good. The equilibrium point or index equal to 3. So this is the expected output. Now let me give another case where we cannot find the equilibrium point. Let me give the same size 6. Let me give 1 2 3 4 5 6. Obviously there is no equilibrium point here. That is to be reported. No equilibrium point. That's all. I hope you understood this code. It is an efficient method. Some people use nested for loop or they will use list slicing inside the for loop to implement this one. The time complexity of that approach could be big O of n square. So in this approach, we are using sliding window method and it is an efficient method which consumes big O of n time complexity and big O of 1 space complexity. Okay, so I hope you understood the code. So if you have liked the video, please share it among your friends, and if there is any issue with this code, please let me know in the comment section. Thank you.